Hi, Ben. All right, cool. I think that's enough, people. Let's get started then. Um, awesome. Can you guys, I just want to test something. Can you see that slides are changing when I do that? Cool. Thanks, Daniel. But yeah, welcome to Camp QMind, everyone. This is obviously your first, I guess, your first lecture of the day or first workshop of the day. Hopefully, it won't be the worst one. But today we're going to be covering some of the, I guess, the most common data science tools that are used. Well, not necessarily in industry, but just in general. The things that we found at KeyMind that are extremely helpful to know before you get your project started. First, I'll do some introductions. My name's Adam. I'm one of the 5 DODs here at KeyMind this year. This is actually my 3rd year at KeyMind. So I'm in 5th year, finishing up an Apple degree. I started KeyMind in my 3rd year. I was a general member, then a PM, and now obviously a DOD. I think you'll hear a lot about this week, or sorry, this weekend. Everyone's going to say how much they loved KeyMind, how much they learned from it, and I 100% agree. I found KeyMind has been a great place to develop some of the skills that I didn't think I was getting enough of in my degree itself. It's been a lot of fun being able to, like, just have a project I can point to that actually I'm like proud of, and people, well, hopefully other people think is cool. But yeah, no, we're glad to have everyone here at KeyMind. Another thing that I'm just going to talk about before we get started is it's kind of assumed that you've worked with Python before, and that you at least have like sort of a development environment set up for this presentation. It's not like strictly necessary, but that's sort of like the prerequisite level of knowledge we're expecting for this presentation and for sort of like the whole data science stream in general. So if you need a little bit of a refresher or an introduction to Python, feel free to just jump off and head to the coding stream. I think that's what their presentation is on right now. But if you have all that stuff set up, then I'm happy to get started. Ooh, actually no. Sorry. One last thing. If you do want to follow along, I have a demo that we're going to be doing a little bit later on. Please use the link provided. I think it's in the general Slack channel, KeyMind Slack channel. There's a link to all the workbooks throughout the whole day, and you can sort of follow along with the stuff that I'm doing throughout this presentation. But yeah, no, with all that administrative stuff out of the way, let's get on to the agenda. What today's presentation is actually going to be about. So, like I said, we're going to be introducing a couple of the most common tools used in data science, or just generally Python development, some best practices for you. I'm going to talk a little bit about why they're useful, and then we're going to hop over to a Jupyter notebook, and we're actually going to demo some of these tools, mainly the libraries that I'm going to be talking about. And then I'll actually finish it off. If we have any time at the end, we'll do a quick Q&A. And those questions don't necessarily have to be about this presentation. It can be about pretty much anything. Yeah, so we'll go over the common tools first. So first thing that I sort of want to talk about is the idea of a Jupyter notebook, or just notebooks in general. They're going to talk about this a little bit in more depth in the coding side of things, or the coding stream. But a Jupyter notebook is essentially just a really nice way to talk about, or sorry, a really nice way to experiment and do sort of experiment or development within like a safe environment, I guess. Essentially what a Jupyter notebook is essentially a Python file, except the code can be split up into cells so that you can run one cell at a time. This makes it a little bit easier to work with big, long programs that you need to, that you don't want to run multiple times. For example, you might have a model that takes 3 hours to train. In a regular Python file, if you, like in a .py file, if you wanted to, if you screwed something up, you missed like a tab in one of your for loops, you'd have to stop everything and run everything all again. And that would be a huge pain, especially if you have to restart your whole 3-hour training time. But with a Jupyter notebook, you just put all of the training related code into one cell, run it once, and then you have that for the rest of your session, I guess. So you can keep those you can keep all of that stuff. You only have to run it once. Jupyter notebooks also have some really nice magic commands. You just use the %sign. I think there's one right in here actually on the top of the first line. The %sign's there, and it just makes you, it allows for some easier things, some easy tricks. For example, like installing libraries right in your Jupyter notebook, not having to switch to a command prompt or anything. And then last thing, if you really want to have cool documentation or cool explanations, or just generally make your notebook look pretty, you can embed images or markdown text within your notebook just to make it look a little bit nicer. The next tool we're going to be talking about is sort of the bulk of this presentation. It's the ML libraries. So there are, I don't know, one of the great things about Python is that it has an overwhelming number of libraries. But these are sort of the 5, I guess, go-tos when it comes to anything machine learning related. We have, first off, pandas. Pandas is a library very, very good at importing, exporting, manipulating, and transforming just giant amounts of data. Sorry. It's great for, so essentially what will happen is you'll have some sort of CSV, maybe you'll have a text file, just some sort of file with a ton of data in it. And you want to bring that into your Python file, or sorry, you want to bring that into your development environment. You can do that with just one line in pandas, and you can then start manipulating the data in whatever way you want very easily. You can do merges, you can join data, very similar to what SQL, like the capabilities of SQL. So it's really great with data science, because you need to, obviously in data science, you're working with a ton of data. The second library I want to talk about is numpy. Numpy is essentially the go-to, probably the most comprehensive scientific computing library out there. What's great about numpy is it has these things called numpy arrays that are essentially just lighter, more compact versions of Python's like native list variable type. What's great about these numpy arrays is that they have extremely optimized vectorized functions, which essentially means instead of having to go through every list of your array or every item in your array and say, I want to take the cosine of that value, you can just in one line say numpy dot cosine of the entire thing. Not only will it do it all in one line, it'll probably do it about 100 times faster. Which is great, especially when you're dealing with, again, large chunks of data. We have matplotlib. Matplotlib is the go-to for making really, really pretty graphs. That's pretty much all there is to it. It's very, I don't know, it's very similar in notation and syntax to anything in MATLAB. So I know a lot of the engineering students get a lot of MATLAB experience, and you have to plot a lot of graphs in MATLAB. It's a very similar experience when you're working with matplotlib. There are some alternatives to matplotlib. I've seen things like Seaborn and stuff like that, but matplotlib I feel like is the go-to. And then lastly, we have 2 libraries I want to talk about that are for like model training, like the actually building machine learning models. We have sklearn here, which is I think probably the easiest and most accessible model development library I've ever worked with. I remember when I first started in data science, I was really like, I was really in the mindset like, ooh, I want to be doing cool stuff. Like sklearn, that's for beginners. Like, cool, complicated stuff doesn't use sklearn. But as I've worked more and more with these libraries and more projects, what I've noticed is that there are very few people, especially in industry, very few people and very few teams that need anything more than what sklearn offers. So I found that most of the projects that people work on end up just using, sklearn models. So it's great to know them and great to know how to work with the library. And then lastly, I think a lot of people have heard about TensorFlow. It gets like a lot of hype. It's Google's own, I guess, model development platform. It allows for more advanced models that require tighter control over what you want, like what kind of optimization you're using. Specifically though, within the sort of neural network space in the deep learning realm of things, because I don't know, that's just what people end up using. And like I said, I was always like, I need to use TensorFlow. I need to be using TensorFlow because that's what all the cool kids are using. And like TensorFlow is great, but it's not strictly necessary. So don't think that just because you're doing machine learning, you have to be jumping straight to TensorFlow. And then the last thing that we're going to be talking about is just virtual environments. Virtual environments are a great best practice for Python that sort of stemmed out of two of the greatest advantages of Python that also created two of like the greatest, I guess, downsides of Python. So one thing about I want to talk a little bit about what makes Python so great to me. To me, Python's great because of its ease of use. It's got simple notation, and it's got, like I said, a giant collection of open source libraries that are very easy to access through pip. Pip is just the library installation tool for Python. What that ends up creating, though, is that, or what situation that ends up making is that everybody can make a library, and everybody wants to make a library about anything. So pretty much any sort of data science related task that you could think of probably has a library, built for it already in PyPy, and that means that, like, downloading a project, or like if you want to develop really quickly, you can just download that library, use it right away, and then go on with your day. But what kind of follows from that is this tricky situation where libraries get complicated really, really quickly. So if you're not using virtual environments, you're essentially downloading all of these libraries on your computer. You're installing them, and you just have all of these libraries and all this like bloat. When, I don't know, one specific project is maybe only using 5 of the like 300 that you downloaded. So what ends up happening is you have all this bloatware, and you also might have different projects that have different versions of the same library. Say 6 months ago you were using NumPy and it was using version, I don't know what they're at, like 20 point something, but now they're at version 21, and you install NumPy again, you're using version 21 now, but you go back to your project that you worked on 6 months ago, and now all of a sudden it's not working because it says you don't have compatible versions of NumPy, and now you're just, I don't know, you have to deal with uninstalling, finding which version you actually had in the first place, downloading that or installing that. It's a huge pain. Also, if you're working in a team, people might not have all of the same libraries, so you can get into situations where, like, oh, it works on my machine, why doesn't it work on yours? I guess you're just screwed. You can't work on this thing anymore. You get all these problems with libraries, and that's where virtual environments come in to really help. They essentially, what they are is a tight, isolated, I guess no other word for it, environment at the project level. So you can just, for each project, you have this small little place that isolates all the libraries that you need specifically for that project. That allows you to produce stable and reproducible versions of your projects, and allows you to share your projects a lot more easily, because all you need to do is just share with them this one requirements file that says, here's all of the libraries that are relevant to this project and the versions. There are a couple examples of virtual environment, I guess, tools. There's Conda, which comes from Anaconda. I think they've recommended that you guys download Anaconda, so you probably have that. But then there's also VEnv and Virtual Environment, or VirtualEnv, which are all great, and I would definitely recommend you guys using virtual environments in your projects. But those are the sort of things that I wanted to talk about. Now we'll get into the actual fun thing, the demo, where I'll actually show you guys the capabilities of some of the 5 libraries. Of the 5 libraries, and just, I guess, try to sell to you why you should be using them and what's so great about them. But let me just switch over to my trusty Jupyter Notebook, and I'm actually going to check the chat here. Jupyter Notebook Pog. Awesome. So today we're going to be going, now I'm just going to be running through, essentially I've created just sections in our Jupyter Notebook here for pandas, NumPy, Matplotlib, sklearn, and TensorFlow, and I'm just going to be walking through these and showing you kind of what's so great about them. So we'll start with pandas, just like before. Some context about our pandas thing here. So here is, I said before, you can import a file in one line, and this is that line. So I have a CSV file full of data about Pokemon in my folder that this Jupyter notebook is stored in. So I'm just reading the CSV in here, and then boom, I have this variable called df, which is a giant data frame. The data frame is essentially what makes Panda so great. It's essentially just like a giant table, a giant 2D array, but with lots of cool functionality associated with it. So I have this data frame object here. I'm showing here, there's like a bunch of ways you can, you don't necessarily have to have a CSV file. You can have a .txt file. You can have an actual Excel notebook. There's a ton of, like, you can have JSON. You can import essentially any kind of file that is capable of containing data into pandas. Right off the bat, I could also say I wanted to sort the data. So I'm going to sort the data based off of the generation that the Pokemon is in and its name. So I'm actually going to print that really quickly. So here I'm running that cell, and now I have this output here. So this is the data frame that pops out here, and I have all of the data associated with my Pokemon data that I downloaded. So here's all of the Pokemon sorted by generation. So these are all the Gen 1 Pokemon, and they're sorted alphabetically. There's that, I don't know, there's a fun thing there. Next thing you could do, I don't know, maybe I wanted to aggregate the data. So I wanted, maybe I want to see how many Pokemon there are of each specific type. So I can do this function called group by, and I don't know, quick do that all in one line. I would think without pandas, that would be kind of a pain. You'd have to iterate through every single item in here, keep track of them, like make sure that the second type is matching. There's a lot of annoying stuff, but here I just literally do it one line. Boom. So now I have this giant aggregated data frame, which is just has type 1, type 2. So here's the amount of bug electric Pokemon, bug fighting Pokemon, bug flying Pokemon. It seems like there's a lot of them. But just quick and easy ways to do things. I can also make changes to data. So I'm changing all of this. So I'm adding this extra column here called total, and it's just going to be a sum of all of their stats. So HP, attack, defense, special attack, all that stuff. And I also want to drop. I'm also going to drop all of these columns. So here's all of the Pokemon and just their stats that I wanted to print. So here's all the stats, and then here's that new total column that I made, which is the sum of all of these things. There's another way you can do things. You can also print more concise notation. This is very reminiscent of MATLAB, if anyone's used it, the like 3 to 16, like rows 3 to 16 and columns 4 to 10, and summing those. I won't get too much into this. Like the point of this isn't to teach you pandas notation. It's more so to teach you what's cool about pandas. The last couple things I can do is I could filter data. So here what I've done is this is a giant check here, and I've essentially said I want their total stats. So this new column that I made, total, I want their total stats to be greater than 500, and I want them to be a legendary. Cool. And I'm going to print their name, the generation, and the fact that they're a legendary. And then here we go. We get all of that all in one line. Great. And then last, maybe this is what I really wanted. All I needed is this filtered data frame. So I'm going to send it to a CSV, and boom, in one line, I've now created a new CSV file with this data in it. Great. So that's hopefully a little bit about why pandas is cool. We're going to move on to numpy now. So numpy, like I said, is great for scientific computing. It has these arrays, these numpy arrays that are really easy to work with and are very similar to lists in normal Python. So what I have here is I have a couple ways of creating an array. You can create an array from a text file. So I'm importing a text file here. You can just hard code one. So this is a 2D array full of floats here. So some great things here. You have zeros. So what this will do is it will output an array of size 2, 3 of just all zeros. Here, an array of like 2 by 2 that's full of 99s. Here we can do an array that's 4 by 2 of all random numbers sampled randomly, I think between 0 and 1, and then the identity matrix for all the fun math things that you might need. And here I'm just going to output, see this random array that I was talking about before. So here's just a bunch of random numbers. You can also check properties of your arrays very quickly. So I'll just output this. So you can get dimension, shape, the type of data within your array, the size of the array, like the number of elements in it. But you can also do some basic stats. You can do the minimum value you find in the array, the max, the sum of the entire array, the mean, and standard deviation. Basic stat stuff. Obviously, you can also change values in here. This is more fun notation. So you can just essentially access values within here. So this is essentially saying I want element 1, 5. I want row 0, all of the columns. I want all of the rows but column 1. And here is sort of a funky one. I want the 0th column, or sorry, the 0th row, and I want from 1 to -1. So I want from the start to the end, skipping 2 every time. So I end up getting here, if we're looking at the array that I instantiated, we have the 0th row, so this guy right here, and I want starting at index 1, skipping, so 2, 4, 6, and that's what you end up putting here. Cool. You can also do a bunch of reshaping of arrays. That here. So if I wanted to transpose an array, I could do that. If I wanted to take the array and make vertical stacks out of it, I could. Or horizontal stacks, that's also possible. So I have this array of 1s and 0s, stack them next to each other, or these 2 arrays here. I can stack them on top of each other. Just fun stuff. And then you can also do stuff. This is sort of where the vectorized things come in. So I have this array 1, 2, 3, 4. I want to add 2 to every single element. So 3, 4, 5, 6. I want to subtract 2 from every element. -1, 0, 1, 2. I want to square every element. 1, 4, 9, 6. Just be wary that, see, we're not assigning anything here. That's why everything goes back to this 1, 2, 3, 4. So just be careful when you're working with arrays that's how they work. Like I said before, you can pick the cosine of every single thing. So here's the cos of 1, 2, 3, and 4. And I think I mentioned in the presentation that, a great thing about these is the time. Ooh, actually, how much time do I have here? How much faster you can do all of these, how much faster NumPy is than just randomly doing this with a for loop. Here's a fun thing that you can do. So see, this is actually taking a while because what I've instantiated is a NumPy array that is 1000 by 1000. So there's 1,000,000 items in this array. And I'm essentially timing how long it takes to calculate the sum of every item in that array with just a for loop, and then also how long it takes to do it with just this mp.sum function. So you can see here with the for loop, it took 4.9, essentially 6 seconds. With NumPy, it took 0.02 seconds, or 0.02 seconds. So you can see there, the speed up is pretty insane. Using NumPy, I don't know, it can just make your computation just a little bit that much easier, that much less painful. You can also do some linalg stuff, but I won't do that here. Next thing, so that's it for NumPy. Next thing we're going to get into is matplotlib. I'm actually going to do a fun little interactive thing, I think. So we have, essentially what we have here is we have a bunch of FIFA data, and I'm going to print to you just to show you what this data set looks like. So this is for anyone who plays the video game FIFA. Essentially, every player has, well, obviously a nationality, an overall ranking, a total potential ranking, and then a bunch of like hundreds and hundreds of stats about what makes them special. So like how well they can tackle, how well they can kick, how well they can run, how smart they are. I don't know. So we have every single player in FIFA loaded into this data set. I'm just printing you the first 5 examples, and we're essentially going to make some fun visualizations out of this data. So what I'm going to do here is I'm going to show the distribution of soccer players by their overall value. So by this value here, I'm going to bin them in groups of 10, and I'm essentially just going to print out a histogram here. So I'm making this is for those who have worked with MATLAB, this might be very reminiscent. So I'm instantiating a figure here. So this is just saying that I want to make a graph. I want this graph to be of type histogram using the FIFA.overall column. Bins meaning like I want to group them by 10, and I'm setting the color here. Then this is just more stuff about, specifying what I want my graph to look like, the X ticks, the labels, the title of the graph, and in the end, if I wanted to save the figure, I could save the figure as a PNG or a JPEG or whatever I want, but I run this thing, and boom, right away, I get the distribution of player skills in FIFA 2018. So you see there's a couple people between 40 and 50, a lot of people between 60 and 70, and then there are 1 or 2 people between 90 and 100. But I can get a nice view of the distribution of FIFA players. Here, I'm doing a little bit of pre-processing. So we have this column called preferred foot, which essentially, do they like to kick with their left or with their right? And what this visualization will do is it'll show the distribution of people who prefer left foot, kicking with their left versus kicking with their right. Same thing here. We have the fact that I'm instantiating a figure, saying I want to draw something. I'm making just some labels and colors. This is saying I want to specify that this is going to be a pie chart with this left and right data that I got before. Labels equal these, colors equal these, and don't worry about this. This is just some formatting for the numbers, and then I'm saying title. Lastly, now I'm going to go ahead and show it. And here we go. We have 76.81%, or just a little over 3/4 of players in FIFA like to kick with their right foot. But now it's your turn. I want you guys to take a second. I want you to read this code, and I want you guys to tell me what you think might come out of this. Plot. So we're going to take just like 2 minutes. Take your 2 minutes, maybe read a little bit, and do just like a couple words on what you think this might actually end up plotting. What kind of graph it's going to be, what kind of data will be in the graph, maybe how the data is going to be split up. Let's see. Range of weights of players. That's good. I was trying to get prizes for this. Unfortunately, I don't think we could get prizes, but whatever. You'll get lots of prizes. There's lots of potential for money here. Pie chart, no clue. So Armin, just reading through the lists here, or sorry, reading through the lines. Yeah, actually, yeah, you're right, pie chart. But that's about it. Classification of player weights in different labels. Yeah. So yeah, I think you guys got it, or at least a couple people got it. So what this should be plotting out is a pie chart that kind of separates players by their weight. So here we go. That's what we have. So you can see there's, in pounds, the distribution of players split up into different weight classes. So 0.23% are under 125 pounds, just over 2 or over 200 pounds. The vast majority are between 150 and 175. So congrats. I don't know who won that, but congrats to you. You get bragging rights. But we'll move on to round 2 then. Same thing. take a second, read this. This one is a little bit more of a tricky one, but I want to see if you guys can tell me what this one is going to be plotting, roughly. A box plot. Well, thanks, Armin. You got it. Killing it. Is it like the average overall of each team? Yep. Dennis, Jordan, you guys are on the right track. That's pretty much it. So that's what we have here. So essentially what's going to be plotted is we have three teams, Barcelona, Real Madrid, and the amazing Toronto FC. We're specifically looking at their overall values, and we're going to be creating a box plot that shows a little bit about the distribution of their overall values specifically for that team. So I'll run that. Here we go, a nice little plot of, or a box plot. So we have the means of all of their overall values for Barcelona, Madrid, and TFC. Some outliers here at the bottom, quantile ranges, all that stuff. But it gives you just a nice box plot of all of the overall ranges. And that's it for our overall rate, or sorry, that's it for our matplotlib demonstration. Now we'll be going over to sklearn. I'm gonna warn you guys now, I tried this morning. I don't know what happened. If anyone wants to look through the notebook, please debug this for me. It was working last week. It's not working this morning. So I'm going to be walking through essentially what this is supposed to do. But some of the training processes I ran and they just decided not to work and we didn't have enough time to debug them. So that's fantastic. So here we have sklearn. We're importing just a bunch of stuff. sklearn, like I said, has a bunch of an overwhelming number of models implementations that you can kind of just pull off of or pull from as you wish. The sklearn sort of thing that I'm going to be doing here is I'm going to be working with the MNIST dataset, which is a very classic dataset. It's essentially a bunch of 28 by 28 images of digits. And you essentially have to recognize those digits. You have to get a model to say that's a 1, that's a 0, that's a 4. So what I'm doing here is I'm importing a bunch of training and testing data, splitting up the value that I want to predict from the input features, and doing a little bit of normalization. You'll see with this sklearn thing that I'm actually going to be using pretty much all of the libraries I was talking about before. So here I'm using matplotlib here, you can see. And I'm plotting out just a couple of some random values of, or some random images within the data set. So I have a 5 here, 0 here, 4, 1, and a 9. That's very interesting. And it gives me a good way to visualize what I'm working with. Here I'm just doing some very, very, very basic exploratory data analysis. I'm just trying to plot out, what numbers, how many of each number do we have in the data set. It's very important. Maybe I have like 3,000 more ones than any other number. It turns out this is actually pretty even, but it's good to know what data I have. And here we get to the actual model making phase. So again, I'm importing a bunch of models, a multi-layer perceptron, a logistic regression, KNN, a random forest, and a support vector machine. And you can see just with 2 lines, essentially, I'm instantiating the model and trying to fit that data to the X values, so the input values, and their labels. So just in 2 lines, I can train a model pretty quickly. And then I was going to print out the scores, but like I said before, for some reason the training just doesn't want to work today. So we're going to skip that and pretend that it worked. And then lastly, I'm going to talk about TensorFlow. TensorFlow, specifically within TensorFlow Keras, which is their sort of neural network creation tool. So I'm importing a bunch of stuff here about different kinds of neural network nodes. You don't really need to worry about this. I'm not going to be teaching a quick course on deep learning. But essentially what we have here is I'm going to make a bunch of neural nets and just show you how easy it is to instantiate some really cool neural nets to tackle this MNIST dataset problem. So we're going to start with just like your classic neural net. Here's with one hidden layer. Here we have just our input layers. Obviously, with the MNIST dataset problem, the inputs, there would be whatever 28 by 28 is. I think that's 784. There'd be that many inputs, and then we can set how many are in our hidden layer, and then we'd have 10 outputs. But here we have, yeah, so we're saying with this, we're creating a sequential model, which essentially means like this kind of flow here. And we want to add a layer that's 78 in the input, and the output is 100. So we're going to have 784 inputs, and then this layer is going to be made up of 100 nodes. And then we're just going to add another layer, just building on top one at a time. And it's going to take its input from this layer. So it's going to have 100 inputs and then output 10 outputs, just like I said. And we're going to compile all that using a specific loss function, you know, all this random deep learning stuff that I won't go over now. But essentially, that's all it takes to instantiate this complicated looking model. We can even take it a step further. Same sort of thing, except now we have three hidden layers. And as you can see, it's just a matter of adding 2 extra lines. And then we have model.compile, same sort of stuff. We can then use these 2 neural nets to, you know, then train our data similar to what we did, or train on our data similar to what we did in sklearn. But I'm just sort of talking about how to make the actual models themselves. And then lastly, if you really want to go overboard, you can make this thing called a convolutional neural network that essentially takes groups of pixels at a time. So it's not taking each individual pixel as its own input. It's taking a group, maybe like of 3 by 3 pixels, and it's going 1, 2, 3 all the way down, and making a new, I guess, hybrid image of the original image. Keeps doing that a bunch of times over and over and over again. Eventually, from here on out, we get this classification side of things. The classification group of the convolutional neural network turns into a little bit more of like what this dense neural network looks like. Won't get into that, but essentially you can create this really complicated neural network that has a bunch of layers just by, you know, add. Just keep adding these layers over and over and over again. Nothing complicated about it. And then in the end, you compile it, and boom, you're golden. So that's pretty much it for the data science libraries and tools that are available. Here are some references from some notebooks that I pretty much pulled all of the notebook stuff from, if you want to take a look. But that's essentially the 5 main data science libraries that I think are really cool, and a little bit of me trying to sell you on why I think they're so cool. But I hope you guys are doing great, and I think that's it for me. I think I'm out of time, but hope you have a good one.